I would share my screen currently and then go to the presenter mode. So now you should see my whole screen, I think. Yeah, do you see the whole screen?
Yeah, looks good, yes. So just the presentation.
Okay, so I think we are good to start. So thanks, Harpreet, for the invitation. So I hope you can understand my English so far. So the topic is adopting Java for the serverless world, and I will be talking from the perspective of the AWS developer. So there are common things for each cloud provider, common challenges, but there will be some specific topics how you can probably solve the problem, because just I'm only deep in the AWS space, so there I can share more. So generally speaking, I'm born in Ukraine, but I live half of my life in Germany and work there. And I have two passions, serverless and Java, and probably that's why also this talk. I'm one of the co-organizers of Java User Group Bonn and also Serverless Bonn Meetup, but we currently pause since 1 year for known reasons. I'm also part of AWS Community Builders Group, where also Harpreet is a part of. And yes, you see from my copy this, and just because all hair salons are closed in Germany since 2 months, so we have just kind of this situation. So I hope to correct this from starting from the 1st of March. Also, hair salons will be open in Germany. So I received my swag kit yesterday, and probably Harpreet is also waiting for his. So I think that's fine. Talking about me, I'm working for the company called ip.labs. We are 100% subsidiary of the Fujifilm Europe. Probably Fujifilm maybe known trademark for many people, but what we are doing in our company, so we provide software for designing and purchasing of the photo products like calendars, photo books, gifts, prints, posters. So everywhere where you can print your photos, so you can print your emotions, like a photo book of the year and so on. We are with all possible clients like desktop, mobile, web, and just 80 people, probably half of them in the software development. And we are doing many things with LWS since 4 years, and since 3 years we are doing things with serverless, depending on the team, completely serverless or kind of partial. And we had a lot of Java developers, and just as we tried with serverless 3 years ago, we jumped into Node.js, TypeScript because of the challenges. But now I think the situation is getting better, and just that's why we are also looking how just probably to move back, because just of many advantages. So let's start with the talk itself, and just to draw the picture where we are currently now. Let's look at the Java popularity, and just there are a lot of sources, and they are completely different depending on the situation, how they are constructed, the popularity of the programming languages. There are kind of job search statistics, or even questions on the Stack Overflow. They're very different, but what is common, Java is probably one of the most popular programming language anywhere. And depending on the statistic, you will see the popularity is something between 15 and 20%, and it will be kind of top 3 programming language in general. Now looking at the AWS and serverless, probably everybody will agree that the AWS is the most popular cloud provider. This is Magic Quadrant from Gartner, and there are a lot of different areas: infrastructure as a core platform, infrastructure as a service, platform as a service. So that may look different, but probably everybody will agree that AWS is ahead in general. And if you look in the statistics, and you will see the links below, and I will happily share my slides. There are a lot of service, which serverless vendor do you use and you will use in the future. And you see then AWS Lambda as a function as a service. So serverless is also way beyond other competitors, like the other 2 cloud providers, or even other solutions like running on the Kubernetes. And this is something I see that the Azure tried to catch up, but still also for the next year, you see that AWS Lambda is way ahead. And generally speaking, we see a lot of rise with serverless. A lot of people are using this, seeing value, and just also they didn't only evaluate or doing proof of concept, so they are currently using this in production. So we see serverless is very hot topic. AWS is one of the best cloud providers. Java is very popular language. So let's look at the life of Java serverless developer on AWS. And generally speaking, comparing to other cloud providers, the life is quite good. So Java 8 support is since 2015, and I hope there are people who are savvy in Java or very interested as Java as a programming language currently here. So Java 8 support is to 2015. Java 11 support is since 1.5 years, so probably 1 year after it was released. And generally comparing to other cloud providers, I know that just they are way behind. So some of them added Java 8 2 years ago and so on. So just on AWS, it's really good. What AWS promises is there, as you know, Java 8 support is not there for free. From Oracle side, they doesn't support it anymore. So Amazon supports this for free with Corretto. So they will support Java 8 since, I think, for 2 years. And what they promised, they will support any long-term version, LTS from Oracle. So after Java 11, it will be Java 17, which will be released this year. So sometimes later, AWS will support this. And just it won't support any versions in between. Just it will be nothing. Java 14, 15, 16, also 18, they won't support this, so they only support the long-term version. But generally not very bad situation. So Java is very mature programming language, but if we will look on the serverless adoption of Java, it looks like this. And just there are several different statistics here. One of these, and they capture here 2 numbers for each programming language. We will focus on the first number. This is the number of all functions, percentage of all functions monitored. And as you see, Java has only kind of 6% adoption comparing to other programming languages. And that's also my personal opinion or what I see when talking to other people. So Node.js and Python are way ahead, and Java as a programming language has the popularity of 20%, but serverless adoption is kind of, I would say, below 10%. And just it's very unsatisfying situation probably. And we will talk about this why. So developers love Java, will be happy to use it for serverless, but there are challenges. And that's why the adoption looks like this. So we will start with simple Lambda basic. I will assume you know this, everybody, but just there are different people probably hearing the talk, and it's important to understand something. So if you create the Lambda function, you choose your runtime, maybe Java 8, Java 11, Python, and so on. But for our case, it's Java, and then you select your memory. And you can select between 128 megabyte until 10 gigabytes. So it was tripled in the end of last year. And if you, for example, double your memory, so you will also your CPU assigned to the function will be proportionally doubled. So just you don't select CPU, so it's kind of function of your memory. So how to create a Lambda function? There are 2 choices. So you can derive from AWS SDK. So you can derive from request handler with input and output, and then you have to implement this handle request method from this interface. It's the only method where you put your business logic. There are also another situation you can say, okay, my Lambda function has this name and this function. So you can just define each function you want, or you may also rely on this function interface from Java 8, which defines only one method apply, and then you don't rely on any AWS dependencies in general. So we will be talking about the situation. So you see just with one interface, one method in the interface is function interface in Java 8, so you can define this way. what you see there comparing that you lose this context object, which is kind of provided by AWS. And it's the matter of taste. Would you like to use this or not? It provides you access to some useful methods. I use the logger sometimes from AWS itself, so I can get this from the context and don't just provide my own one. And sometimes you can log things like get remaining time in millis in case you would like to trace how close you are to the timeout, depending where you're in the function. So there are some useful methods, but generally you can choose what you would like to use. So concerning the price model, probably also known thing, you pay for the request tier. The number of requests, it doesn't depend on the programming language. It's up to your architecture, and also for the duration of the execution of the function. And it's, of course, here it depends on the function itself. So you pay 20 cents per million requests, and then you pay per gigabyte memory assigned. So just if you assign your function 1 gigabyte of memory and then it runs for 1 second, you will pay this amount. So simple example, if you have 1 million requests and you have selected Lambda with the half of the gigabyte memory, then yeah, and each Lambda takes 200 milliseconds, then you pay this amount for the request tier, and then this amount for the duration tier. And in the end of the last year, so it won't be rounded up. So until the end of the last year, the duration tier will be rounded to the next 100 milliseconds. Currently, you pay for the amount, for exact amount of execution milliseconds. So if the function takes 150 milliseconds, then you pay for 150 milliseconds and not 200 milliseconds more. So just also nice a change on the AWS side and on your build side. So now speaking about the challenges, and of course it's always number one, this is cold start, and probably also everybody knows what it is, but generally speaking, the life cycle of your function consists of 4 steps. So first of all, your code will be downloaded. So if you upload your function code in AWS, it will be S3. Then execution environment will be started. Execution environment is Firecracker VM, and then the Java virtual machine will be started. Then, so probably can go next. So the next thing, the Java runtime loads initializes the handler class, so the function class. And then the third step is init logic will be executed. This is static initializer of your function. So this everything outside of your function. And these 3 steps, the first steps are called cold start, and the fourth step is just the handler function will be executed, so the function logic. And what is very important in this static initializer phase, you will get the full CPU access for 10 seconds. So if you have some kind of logic outside your handler function, you will get the full CPU access for 10 seconds so you can speed up the things. Otherwise, and it's very important, you will get the full access to the full CPU only if you assign 1.8 gigabytes of memory. So in case if you assign kind of half gigabyte of memory, you will roughly have 30% of CPU cycle in your function. So it's very important that in the static initializer phase, you will get anyway access to the full CPU. And of course, then you can do things quickly. And it will be very important in case of pricing and what you can do to optimize things. So just once again, this kind of cold start, it happens not only with the first execution of your function, but also in case you have newsletter sent and you have 10 requests at the same time and you have 5 warm containers and you can only execute the function in the container 1 time. So then other 5 containers are missing and they will spin up and have also cold start. So just it's also about how many execution in parallel you have and how many warm containers do you have. So just if new containers are needed, because they won't be reused until the function is executed until the end, then it will be returned as a container. And sometimes after 1 hour, so it will be released, the container, because of security reasons. So just the new container will have to start up. So of course, there are also other dependencies, and this dependencies cold start is also dependent on the programming language. There are a lot of statistics, and probably each 3 or 4 months, everybody publishes something new. So this is kind of new statistic from the end of the last year, where you see it very simple hello world function in different programming languages, and you see the cold start in Java is generally with the simple functions kind of more than 1.7 milli, 0.7 seconds. And you see JavaScript, Python, they have reduced cold start, and it's also one of the reasons of this huge adoption. And you see C# and just comparable language to Java, it has also the same challenges. And Go is kind of comparable to Java. But the situation is that this is kind of below 1 second cold start latency for simple lambdas like hello world, where you don't do anything and you don't have any dependencies. It's not the reality how we write our application. So if we have some kind of business logic with dependencies to other AWS services or other third-party services, you would like to pay with Stripe and so on, so you have to include dependencies. So this cold start will go up, and we will see how much. It also depends on the artifact size. So how big is your application? Kind of zip, but you package this with jar and so on, but just you package all the dependencies. And Mike Roberts, who is the author of just serverless development with Java, has analyzed this, and you see different artifact sizes, very small and big, bigger. And this ABBA jar is then you have only one jar, and every dependency is kind of packed together. So you don't have different jars within it. So this everything is unpacked and then packed in one jar. And there are a lot of colors, probably difficult to see. So you see all these big jars, so large jar and ABBA jar, they have cold start latencies up more than 1 second. And what you also see for the small artifact sizes, then the cold start latency is kind of acceptable. So what you see this is the situation that just more dependency also means longer cold start time. And if you don't use best practices, we will be talking about, it's not common to have cold starts within the range of 10 to 20 seconds. That's a normal thing. If you don't read how to improve this and you will do things just, okay, let's try that, that's probably 10 or 20 seconds. And then people have kind of shock. Yeah, just it's not acceptable, even if it happens not too often, that just somebody waits for 20 seconds, even if it's only one person from 100. So then coming back to this benchmark, what they told 1 year ago that the Java adoption will increase in the last year, and they told that provision concurrency and VPC improvements are 2 areas to pay attention to that will improve the situation, and they improved the situation. So provision concurrency, everybody can, I think, understand. So this is kind of, you have newsletter at 9 p.m. and you send them to millions of people, and so just people will receive them in the same time and probably hit the link, and then just you need too many containers simultaneously warmed, otherwise people will experience, a lot of people will experience cold starts. So the solution for this is for some period of time to prepare and to have warm containers. So just you can start this, you can provision them from 8 o'clock, 15 minutes until 10 o'clock, just to have some defined number of warm containers. You have a bit of managing effort for this, and of course you have to pay for these warm containers, and it doesn't depend if they will be used. So if nobody clicks the link, then it's your problem. But it's kind of the situation for just to avoid this cold starts if you expect a lot of traffic for some known period of time. And sometimes we know this period. So this is kind of trade-off. You pre-provision and pay for this versus scaling on demand. Another thing is this VPC, and it's probably very complicated for people don't dealing with this, but generally speaking, there are some services like Elastic Cache This is managed Elasticache with this Elasticache Redis Memcache solution, relational database with one exception, also Elasticsearch. If you would like to access them, and also RDS proxy is the new service. If you would like to access these services from Lambda, you have to put Lambda behind the virtual private network, because all these services require setup also behind the virtual private network with some exceptions. So what was the problem 2 years ago? If you also had the cold start on the VPC, it added additionally up to 10 seconds because of the internal architecture, how AWS did the things. So you have 10 to 20 seconds on Java cold start, and then you have the worst case, and then you have VPC cold start, then you have additional 10 seconds. So it's hugely unsatisfying situation. So AWS improved the architecture. So this the whole scaling happens, then you deploy the function, and this reduced the PC call starts from 10 seconds to below 1 second. So probably nobody should read this kind of how it's done. The main thing is it's done, it's rolled out on each region, and it's really better. But of course, so not everybody uses virtual private network when communicating Lambda, but in case if you're relying on your relational database, it was a huge improvement. So let's talk about how to improve things with Java functions itself. And the first thing is switch to the SDK version 2.0. So you have the older one, 1 point something, and this newer one has a lower footprint and is also more modular. So in case you would like to communicate to the outside world, then people running server applications with Java, they use Apache HTTP client, native, and so on. So these HTTP clients heavily rely on caching, but they are also very slow, and they cause also cold starts. And for Lambda application communicating with the outside world, even the simplest HTTP client is enough, and Java provides a HTTP array connection client. But also AWS added several months ago its own asynchronous common runtime async client. So try it out, it's very easy to use, and it provides the best experience for the serverless application. So use modular new SDK and use this asynchronous HTTP client in case you need to communicate outside. Another thing is provide all known values when you're building like clients like DynamoDB client, S3 clients, in case you would communicate from Lambda to other services. And you know your credential provider, you know your region where you are, you probably know your endpoint. So you can provide this, because otherwise AWS should figure it out on their own. They can, but there's a very huge chain how to figure it out, for example, with a credential provider. So just they have 20 implementations and they try, okay, can I find something for this implementation? No, okay, what's the next chain and so on, and it takes seconds. So you probably know where you stored your credentials, so provide this. So other things is in just really hacks, and the people who program clean Java will say it's horrible, and it is. So make use of this full CPU access in your static initializer block. So in case you would like to instantiate DynamoDB client or S3 client, do this. You need this only one time for your function, for the life cycle of your functions. So do this outside of your handler in this static initializer block, because just you have full CPU access and you can do this more quickly. But there are also other things which can be speed up there. This is, for example, if you use DynamoDB and you would like to read item or put item into DynamoDB, only if you call get item or put item, then this so-called Jackson marshaller will be initialized. And Jackson marshaller is something like serializing, deserializing objects into JSON and then other way around. And it has some kind of initialization phase. And if you can move this logic into your static initializer block and some kind of fake this, so for example, get ID with ID 0, you don't need this number, but if you call this one time for your function, then it's pre-warmed, and the next call where you receive dynamically your ID will be much quicker. And once again, doing this in the static initializer block makes things quicker. It's really faking some call when you have more CPU, but it kind of works. So another thing is, of course, probably everybody knows, but don't pay attention. Put only dependencies that you require. So don't import the whole SDK version 2.0 with all APIs for calling SQS, SNS, event bridge, and other 100. So you probably don't need this in your function. So if you only need DynamoDB call, so import only DynamoDB and just don't import other stuff. And of course, also exclude things that you don't need in production for testing, like scope test, like JUnit stuff and so on, which you don't require. Remember, it's about the artifact size. So there is another thing which is probably kind of not very well known, and it's this Java class data archive sharing. So the thing is that you can run your function, and then first time you terminate the function, you can store the whole representation of your function, including the whole JDK, what is in memory on your disk. And then you load all the classes from the disk, from this representation. It will be much quicker as just loading the whole JDK and so on. The situation is it was heavily improved with Java 13. And as you know, there is no Java 13 managed environment. We have Java 11, and the next thing will be Java 17. But generally speaking, we'll be talking about Docker. There are ways to use Java 13 also now. So think of this is kind of extension. It was introduced even in Java 10, but there are no option on shutdown. Now they are there, so you can improve things and or wait until Java 17 will be a managed environment. But generally speaking, what you would like to avoid with serverless, and what you gladly do with your server application with Spring and so on, is just we would like to avoid reflection, everything on runtime, bytecode generation, proxies, class loading, and so on. And that's probably the thing that people say, oh, how may I do this? I use Spring, I use Google Juice, and so on, and they heavily rely on all those things. And then we will be talking about other options like Micronaut, Quarkus, and there are also lightweight dependency injection frameworks like Dagger and so on, so where they are not reflection-based or have other trade-offs. So another thing is just strive for cost optimization. Yeah, and remember you have request and duration tier. And with the duration tier, you know, if you assign more memory, you will get more CPU. And the question is, will it be more expensive? So in case, I double my CPU memory, I will also double my CPU. And the general question is, figure it out. So there are tools, and we'll be talking about the tools using Java on AWS. And the first one is from the Lambda power tuning from Alex Casalboni, working for AWS itself. It's kind of state machine with step functions, AWS step functions, where you can test what combination of memory and cost is the best fit for you. So you give the options, and then the function will be run and tested, and you will have the result, what's the best match. Like this, the situation you see kind of example, you see the memory used, and then you see execution time. And of course, execution time is about the cost. And then you see some kind of sweet spot. So just in case, so if you give your function more CPU, it may run quicker, and then you pay nearly the same amount, but it will be executed much more quickly. So figure it out. There is also another tool released several months ago, Lambda cost and performance optimization. So it is a part of AWS Compute Optimizer, which is for free. And you can also test the function for, I think, 14 days, Lambda function, and then you will receive kind of recommendation. And you see this function is memory over provisioned, and they suggest you to assign less memory because it will be as quickly or comparable quickly, but you will save kind of 10% until 15% of the cost. So The difference is that the previous tool analyzes this not in your live environment. So this is kind of quick test. And this tool analyzes the live environment for a real execution for the last 14 days. So there are also other tools which may ease your life as a Java developer. Is also Power tools. There's one for Python and one for Java. And it eases your life that you can easily configure services like tracing with X-ray, logging and metrics with CloudWatch. And just simply the matter of importing them, just declaring them your POM file where you declare your dependencies. And what is really important that all these Aspect.J plugins, they will do the things on the compile time. So you trade the compile time, but there is nothing, no magic happening in the runtime, which costs you probably time, and time is money with serverless. So just one example how to do this. So you declare here the logging, and you say the sample rate, only half of the requests will be logged. The same is for tracing. So just it will go to an X-ray, and then this is for metrics, and you can capture even cold starts true, and then you will see everything kind of in also in your CloudWatch. Probably one of the newest tools is this kind of helper method for testing your function with Java. So previously you have to write all this code, just the logic to serialize the things, to test some events. So now you have kind of this event loader for your tests, and then it simplifies the logic. So this is on the right side, you see the same as on the link side, this kind of helper method just to offload this logic that you have to write, and then it makes things easier. That comes also from the community. And generally speaking, you can see here a lot happening with AWS Lambda Java libs. So rather a lot of projects here which may simplify your logic and also do just check it out. There is a very vital community for this. So generally cost optimization, Java is very well optimized for running longer server applications, where you start your server and it's just there for weeks or months until you redeploy something, and there you have high startup times and also high memory utilization for those server applications. And as we know, this is kind of memory and execution time are dimensions or cost dimensions with serverless in each cloud provider. So now GraalVM enters the scene. And what is the GraalVM? It has many meanings, but it's also kind of ahead of time compilation. We'll be talking about this for JVM based languages. It also provides interoperability, so you can mix languages within your code. It's not what I do, but generally it's possible. And this is kind of architecture, how it's done. And the talk is not about the GraalVM architecture itself, but what's important is you can define this substrate VM on top of your Java hotspot VM, and this will give you this access to the ahead of time compiler. Yeah, so probably that's what is interesting. So I don't think that people will run Node.js, C++ with GraalVM. So many people stop there for running Java JVM languages like Java, Kotlin, Scala, and also Groovy. And what this substrate VM provides you, it's kind of ahead of time compilation with the native image. And ahead of time compilation is general term. So you will try to compile everything ahead of time. So you have to identify all reachable method, fields, and classes. And then in your application, which will be required in the runtime, and then it will be compiled, and then it will be the native image of your application. Native image for Linux, it's 1, for Windows, it's exe, and for Mac, it's Mac-O. So depending on the platform, you can provide native image, and that's the difference. If you have GraalVM or substrate VM with native image, you don't have kind of Java there. So Java is also dynamically executed, but with some kind of thread management, garbage collection, and so on, some basic functionality, but just Java is not native precompiled, so it will be dynamically executed. So what are the benefits of this substrate VM or ahead of time compiler or this native executable, it reduces the cold start time very heavily. So you have cold start times and also memory footprint because you only package what you need. So everything else which is not reachable will be thrown away. And these applications start very, very fast. So that's common that they start within 100 milliseconds. So it's even better than with JavaScript and Python. But of course, you have the complexity of this building step of this native image and all the complexity, but that's the possibility just to reduce the cold start times from several seconds to 100 milliseconds. But of course, if the life would be so easy, then probably everybody will use this. So what are the challenges of native executable? So most cloud providers only provide Java as a managed runtime. So you don't have, and GraalVM is its own managed runtime, so it's not provided. Yeah, so you cannot select GraalVM. But some providers on AWS have support for kind of custom runtime option, and there you can provide your own runtime. And with AWS, there is a possibility to, with Lambda layers and Lambda runtime API, provide your own native image. And you have to package this like function zip, that's normal, and then you put inside this bootstrap file. So it should be called bootstrap, and then you can provide the native image built with GraalVM for Linux, because custom Lambda runtime supports only Linux executable. So you have just to have the GraalVM native image for Linux, and then you can compile this to the bootstrap file and then package this to function zip. And this way, then you can deploy this on AWS, and other cloud providers have similar constructs. And we will also talking about Docker. So what GraalVM gives you, it gives you the possibility to decide, do you want just-in-time compiler, a normal compiler that people use, or you would like to use ahead-of-time compiler for your application. And of course, there are trade-offs. So just-in-time compiler is for peak throughput and reduce maximal latency, so for long-living applications, and ahead-of-time compiler optimizes your application for start time, speed, low memory footprint, and small packaging. All these are factors of cost factors of serverless application. But of course, building ahead-of-time compiler takes time, so you trade off kind of productivity, because just you have to wait 1 minute or something like this until a native image is built, and then you will deploy it, and then you can test it and so on. So just a bit different experience. But the situation is many people use Spring as a framework. So just it's probably the most popular framework for building Java applications. And of course, Spring doesn't have these trade-offs. And of course, now we will be talking very briefly about how other frameworks help here with Quarkus, Micronaut, and also how Spring aims to improve the situation. So all these frameworks have their common principles. They rely as little as possible on reflection. So they avoid doing everything on runtime. They process also annotations at compile time, and they have common goals, also increase developer productivity with these frameworks. And of course, just speed up start time and decrease memory usage for microservices and serverless applications. So they are even good for microservices application where you scale up and down and you don't have servers sitting for too long. So just each server can come and go each time. And they do it with GraalVM native image and also without GraalVM. So you can use pure Java without native image. They also find a good trade-off between productivity and just also costs. But of course, native image is way beyond if you're only thinking about costs. So let's start with Micronaut. It will be very, very brief examples how they do this. The whole magic is behind the scene. And if you write some kind of Java function, a Lambda function with Micronaut, it's probably only one thing that you see with Micronaut is with function bin. Yeah, that's only one dependency. That's totally normal Lambda function, which derives from function interface. So there's no magic in your code. It's very easy to adopt things. And what you see, there are two different situations. So Micronaut provides you custom validators, also access to API gateway if you have public facing annotations. But I would really like it. You can have your Spring application and use so-called annotation processor for Spring annotation, and then you don't need to use Micronaut specific annotation. So you can easily convert Spring application to Micronaut application and have all these advantages of the Micronaut. So in case you're using Micronaut annotations itself, like this function bin, then you have to use this on the left side, annotation processor for Micronaut. So there are also plugins, depending if you use Gradle, then there is a plugin. For Maven, there will be plugin which allows you to build with this plugin Graal native image by hitting this simple command, but you can also build Docker and also even native image within Docker. So just everything is possible. So Micronaut comes from Graham Rocher, so people know him for Groovy programming language and Grails. And what is interesting, he joined recently Oracle. So I expect kind of collaboration between Oracle and Micronaut, because just to improve this framework, just to become more adopted for serverless. Of course, there are other choices, similar framework Quarkus, which comes from IBM and Red Hat. And even I think Microsoft is there. So the similar things now we are deriving from AWS SDK interface, but just you can use also function interface. You don't even see any logic of Quarkus here for building the function. So everything is in Maven, so for building, and the same thing, you can define your Maven plugin to build the native image. So just define your profile native and then define your goal native image. And then with this plugin, you can simply build the Linux native image of your application with Maven -p for profile native package. And then you have your bootstrap file, and then you can package this with function zip or use Maven plugin for this and so on. So just this is the alternative. And Quarkus is about microprofile standards, so they heavily standardized thing, and Micronaut uses their own packages. So there are not many standards there. It depends on your context. So what Quarkus adds additionally is support for Funky. And Funky is kind of multi-cloud solution. So you can write one function and then deploy it on big 3 cloud providers like also Azure Functions and Google Functions, and even Knative if you're doing Kubernetes. It's up to you. I personally don't like something like multi-cloud, because I don't think that you can optimize for all cloud providers, and then you have to use the common services, and just you can't rely more on SQS and so on, which are specific to cloud providers. So I'm not a huge fan of it, but there are probably some environments that the people have to adopt the application for several cloud providers in parallel, because this kind of requirement to move quickly out in case of, I don't know, price increase and so on. So, and the third one is Spring Boot framework. So the situation with Spring was they started 16 years ago and they heavily rely on reflection. So, but they saw just Spring Boot and Java and serverless, they don't match because of all these disadvantages in the runtime. So they started collaboration with GraalVM and started the project called Spring GraalVM Native Project. They were tried to rewrite some kind their logic to adopt this for serverless application. They started 1 year later comparing to Micronaut and Quarkus, so the metrics are behind currently, but they will probably catch up. And then you see this is the function. It looks like the Micronaut function, very similar. You have auto-wired and other Spring annotations, so there is no magic. What is currently very inconvenient is that you have to define application class, and then you have to define all your beans. So this is the bean which we defined, this Spring, the function which we wrote, this one, so math invoice generator function. So you have to declare this with one more step, and then use this annotation just to provide some magic behind the scenes. And just that's what you don't do in other with Micronaut and Quarkus. So you don't have this additional step. Probably it will disappear because it can be automated, I think. And the same thing, you have the plugin to build your GraalVM native image out of the box, and you can even configure build arguments, additional arguments. There are a lot of arguments, things they can pass to build the native image. You can heavily configure it. So very, very flexible. Yeah, but anyway, you have currently the choice. So framework comparison, I won't do this in depth because there is a huge speed of changes there, but generally look on the initializer phase. So how you can initialize the project. You need command line or kind of web interface, programming model, database support, test support, and also standard like micro profile, yes or no. But what is important for me for the serverless application, if you use this frameworks plain without GraalVM, then there are this criterion which is important: application size, startup time, request invocation duration, memory consumption. And in case you use native image, what is important is to build, how much does the build take? It depends on GraalVM, but also on the configuration of the framework, and native image size is the question. Other things are mainly comparable. So that's up to you. So I think that Quarkus and Micronaut metrics are close to each other, and Spring Boot is behind on all these topics currently. So it takes more memory, it takes more time to execute, and of course that will cost you more, because of course Micronaut, they are only optimized for microservices and serverless, and they don't have the baggage of all dependencies, so they can move quicker. So now in the end of the last year, there was container support released. So Docker container support released with the image. So you can just make the Docker environment and then execute a function there. And of course, what are the use cases of this container image support? The question is, hey, currently there is, I think, Java 15, and AWS supports only Java 11. So just there is a 2 years and can be a 3-year gap between what I can currently use with Java and what AWS supports. So just very simple, you can use the newest Java version 15 and build the Docker image with this, and then you can deploy the Docker image. So write function and then deploy the Docker image for this. If you really want to manage your Docker file, then that's the option for you. And so the situation is also, there are also some situations then you use other languages, like not only Java, but also Scala and so on. And GraalVM itself also optimize these languages even better as standard Java. So you can use GraalVM without native image. So you can use also GraalVM packed within your Docker image. So you don't really need this native image. So you can just simply take GraalVM and package this into the Docker file. So in case of situations, so check your metrics, check what's more convenient, and just decide. So probably the conclusion, so we are currently about 1 hour. So I know that the attention drops a bit. So GraalVM and all these frameworks are really powerful with a lot of potential. And Micronaut and Quarkus will improve the cold starts of Java application even without GraalVM and native image. So use them with Java as a programming language, and it gives you the best trade-off with productivity and cost. And because all this no reflection stuff and so on, and I see people report something about 1.5 seconds for the cold start time with Quarkus and Micronaut. And if you just don't experience this too much, then 1.5 seconds in 1% of the situation is probably good enough, and you don't need to adopt the native image and complexity. But in case you would like this, you would like combination, you would like to adopt the native image because you have very hot functions and just they are pricey, and you would like to just to speed up and to reduce the cost. Think about this. AWS custom runtime requires Linux executable only. Yeah. And also Docker image should be Linux, and managing custom runtimes requires some additional effort. So it's not the managed runtime anymore. So you are responsible for securing your runtime. So, and for updating this and for managing the images and maintaining your images. And what is very important for custom runtime, you will pay for this initializer phase. Yeah, we also have yeah, from outside of your handler. You will pay for this, and if it's the managed runtime like Python, Java, these 10 seconds are for free. Maybe a very important situation for you, depending on your use case. And of course, if you deliver some execution runtime like Java with your custom runtime, it will drop a bit of performance because just AWS uses SAM API to call this, but it's, yeah, that's probably not very noticeable. And yeah, but it will reduce your cold start. Native image reduces the cold start to several hundred milliseconds, really 100 or 200 milliseconds with very low memory consumption. So it will also reduce your costs. But you have to play around with a lot of additional flags. Here's the link. So just I also had the problems to compile this native image that it runs without the problem. I had to play around with the things. Of course, if you are doing this one time, then just probably you know how to use this. So probably personal recommendation, it's very highly opinionated. So the situation is, by default, use Java long-term support version with Amazon Corretto, currently 11, and your favorite framework. So the default situation with 1.5 seconds call time, default situation, that's totally fine. Decide what framework is up to you. If you need constantly low response time for known period of time, so you know I need this high performance in case I send my newsletter, use provision concurrency additionally. So pre-provision the things, pay more, but you will have the best user experience. So if you have some functions really low response time and low cost as a requirement, so because they are so heavily used, then think about using GraalVM native image with one of the frameworks. And you can think of this with Lambda custom runtime and also with it, probably also Docker image and so on. Probably in order to speed up your local test, define two pipelines for quick tests without without native image, and for production tests with native image, just to be able to test very, very quickly. And in case if you don't want to miss 3 years of innovation with Java, yeah, and you would like to use the new features which make you more productive, and also there are a lot of frameworks which also rely on this new feature, then try this container image support. It gives you the best, yeah, then you can package the newest Java version there. So probably the last thing is, where can AWS help? So there are a lot of discussion there. So Corretto should be optimized for Lambda and for Java. And many people say, so rethink the garbage collection. So many function, so garbage collection takes time and also takes memory. And sometimes just if the container will be released after 1 hour, it's probably okay not to garbage collect at all. So just, yeah, don't take the memory and just don't take processing time, just don't do nothing, and then it's okay. And probably rethink hotspot just-in-time compiler optimization. So this just-in-time optimization, they will be activated after 10,000 of executions of the function, then something will be optimized. And sometimes just the function cannot be executed so many times before the container is released. It doesn't make any sense. So just probably fine tune all these things, and probably provide the JLink support. So what JLink support does, it provides some subset of JDK. Probably not everybody requires all this JDK dependency in his application. So people use subsets in case database access or not. If somebody uses only DynamoDB, doesn't need to use like relational database drivers and so on. So probably you can pre-configure your Java runtime images with JLink and give you some more options, and then you will have lower artifact size, and then you probably can start up quickly. And see what Oracle introduced with FN project. It's their own project, so kind of Lambda, but just for Oracle Cloud, or you can run it, manage it in Kubernetes. They have tuned a lot of what is said here just to become more productive. You can try it yourself. So there are links for Micronaut, Quarkus, and Spring Boot, and the last link is from the AWS Lab, where you can see the examples from all of these. And probably I think that's okay. The last slide is there is so-called Project Laden. It's the new project, or this call for discussion, which is started from Micronaut, who is the chief architect for Java. And he says he would like to see this native image capabilities in the Java as a programming language itself, and not with GraalVM, which is kind of parallel stream. The discussion started in April last year. I don't see anything happening there, but in case it will become the part of Java, then you can probably use this selecting Java as a managed runtime version, so you don't need GraalVM as a separate stream and don't have to build Docker and so on, or native image with custom runtime. So it may probably make things easier, but I think we are 5 years from now before something happens, because it's only call for discussion. So thank you very much. I think I had a feeling that was too much information probably, but I wanted to share you without time pressure, which you normally have in your conferences. So now I will be happy to answer your questions if you have any. So thank you very much.
Thank you so much, Vadym. So guys, the floor is open. If you have any question, or you want to voice out anything, you want to clarify anything you want, or if you don't have access to the audio, or you're a bit shy, you can also drop a message. Just give them a minute or so. Maybe I'll begin with one question regarding. I think technically the presentation was awesome. I think we learned a lot about Java in general and what we can do to optimize it even further, and take it really to the edge. But just from the team transition point of view, like whenever there is a Java project, something like even for a medium project, something like Spring Boot is given, right? So how was the transition in your teams like, or things that you've experienced around or you've heard about? So how were the teams able to transition from giving up all that, because Spring is not just for dependency injection, but also all the libraries that we get out of it for the data and for all the other helper functions. So how was it the transition like? Was there a training and all, and how did you go about it? So moving from that kind of a stack to what we saw just now in your talk.
Mm-hmm. So as I told at ip.labs, we are doing a lot of things not with Java. We are currently thinking of coming back. We did some project with Java and serverless in the beginning, but they are not very public facing, so we don't have kind of struggles. But generally thinking, of course, with Spring, you have a lot of dependency injection, but also Micronaut gives you the similar model of the dependency injection. They are really the same annotation names, and they give you the possibility to inject things. So the experience is very, very similar. But of course, what Spring gives you more is kind of easier way to write to the relational database and just things to validate. The situation is you can use Amazon SDK to write to the relational database, but often you use DynamoDB, and then Spring can help you anyway. So you have to rely on AWS things. So just by using all these managed services from AWS, you simply eliminate many strengths of Spring and many things that you can just do Kafka and some other streaming and so on, because they are kind of well integrated. So you don't need this. What you of course need is a kind of validation, kind of simple dependency injection of classes, and Micronaut and Quarkus, they give you this experience anyway. So just you have a bit to relearn what are the annotations and so on. And generally speaking, the transition is not very heavy. If you say, I don't want to use Micronaut and Quarkus, I would like to write plain Java, then sometimes you see, oh, then I have to write more code. Yeah, that's the situation. But then I have less dependencies, and then it's also just the advantage. So this kind of mixed feeling, but I'm pretty well with Quarkus and Micronaut helping just to do the things I knew from Spring Boot.
All right, so thank you. Thanks for answering that Vadym. So I think we just have a message in the chat. Let me just read it for you. Okay. All right. I think it's not a question. It's more like a thank you. All right.
Thank you. I will accept it after the talk. I won't leave. Yeah.
Yeah.
Thank you.
So, all right. So I think we have this maybe one more sec. Like, does anybody have a question still before we close? It could be in general about Java, serverless, anything that comes to your mind, because I think Vadym knows a lot, so he would be able to happy to answer you on that. 1, 2, 3. Okay, all right. I think not. So I think mostly then I think we should be able to close now. So thank you so much, Vadym. I think we are already a bit up time, so I think, and you have some other further engagement. So thank you so much. I think I personally learned a lot, and I think just like the messages that are coming, so it was people also found it very informative. So thank you for taking out the time and doing this, and all the way from almost the half of the other side of the globe. And all of us learned awfully a lot from. All right. Thank you so much, Vadym, and thank you everyone for joining.
Thank you. I will make PDF. I have SlideShare to upload, and I will post the link into the Meetup page of this presentation, so you will see it. But of course, Harpreet can share it with you anyway. You can contact me and so on via Twitter, LinkedIn, everything. So you will see this contact details.
Yeah. So for this year's talks, I plan to do. I plan to record the talks and put it on the YouTube. So I think we can also do it together. Also provide the video and as well the slides that will share, so that everything in a single place.
So of course you can cut the video and then you can publish it. So just it's totally fine for me. You can publish it on YouTube on how you want to distribute this. Everything is fine. So
okay, everything.
I will retweet and so on. Thank you.
Yeah. All right. Thank you so much. Thank you again, Vadym, and thank you everyone for joining. See you next time, and feel free to ping me if you have anything to share on your side. So as I said, it's not only for a meetup. Yes, there are experts like Vadym coming, but even if you have something to share, feel free to reach out, and we'll arrange something in upcoming meetups. All right.
Yeah. Thank you.
All right. Thanks again. Bye bye. Thanks.
Bye.
Bye. See you.